Let's just very briefly recap what we have already done. On the first day, we looked at the Stata interface. We familiarized ourselves with the working principle of Stata and also the concept of working directory. Then in the last session, that is the second session, we looked at the structure of data set and different variable storage types that Stata admits. And then we saw how to load a data set and work with variables. Now, later on, when I was myself reviewing what I did, I suddenly recognized that I actually have missed two things, partly because I forgot and partly because of paucity of time. So before starting today's actual discussion, which I have been talking about from the first session itself, which is reproducibility of our work, before getting into that idea, what I want to show you is two things. One is, on the first day, we looked at the display command or the display dialog box if we are working through the menu. And there I showed you how to do some calculations, basically how to use Stata as a big calculator. Now, definitely that seemed to most of you like kind of baby calculations. However, and it seemed like, okay, most of the calculations we probably don't need Stata to do. We can do it with a hand calculator as well. However, there is one thing that becomes very crucial if we are working with statistics, and that is remind yourself your statistics classes. And at whatever level you did your statistics class, you definitely have done hypothesis tests. And in hypothesis tests, towards the end of the steps, two things that we had to do always was either calculate the p-value or the critical values now to do the test. Now, what did we do when we did not work with computers? We had the tables at the back of the textbooks, and we looked at the critical values from the table because we chose some level of significance like either 1%, 10%, or 5%. And based on that, depending on whichever distribution we were looking at, whether it is standard normal distribution or students t distribution or chi-square distribution or f distribution, or depending on what particular test you are doing or you were doing, you looked at that particular table, and then from the table you figured out what is the critical value or critical values that are necessary to do the test. Now, the moment you have access to a statistical software like Stata or any other statistical software, you do not need to look at those tables anymore. Stata can actually, or any other software also, can actually calculate those p-values and those critical values. So that is something that we will look at. I will show you first. So I will kind of go back to the first session a little bit and show you how to use that display dialog box, which translates to the display command to figure out or to calculate the p-values and the critical values. So that is one thing that I want to show you, which might seem like to many of you like more practical usage of the display command. Sorry. And the other thing that I want to show is in the last session, I was talking about creating variables. And most of the variables that I worked with, not most, all of the variables that I worked with were numeric variables. So we added variables, we subtracted, I think we took square of a variable, I don't exactly remember, something like that. But one part that I kind of did not talk at all about was that there is another type of functions available in Stata. So one type of variable storage, which I discussed in last class, was that string variables. So from my discussion of creation of variables, it might seem like, okay, so Stata can work with a lot of numeric variables. It can create numeric variables in different ways. but probably it cannot do much with string variables, but that is not the case. So I will show you 2, 3 examples, and then you can gradually, as you need, you can see that there are lot more functions available which are applicable to the string type variables. So those are the 2 things that I want to finish first, and then we will get into reproducibility. But before I do that, someone has written something in the chat box. So let me just check it. Okay. All right. So that was not a question in the chat box. All right. So let me just directly go to Stata and show you these couple of things. So the first thing that we are going to do is calculate the probabilities. So let's say this first problem that I have on my Microsoft Word page, which probably you guys can see. If not, let me know. So what I have is probability of a t variable which has 5 degrees of freedom. What is the probability that it takes a value less than 3.21? So that's a probability related question, and we will use Stata to calculate it. Similarly, another thing is, which the next thing is actually something like a p-value calculation, basically a right-sided or right-tailed p-value. So if there is a t variable which has 20 degrees of freedom, what is the probability that it takes a value greater than 1.96? So we will see these two. And the third example that we will see is the other side of the coin, that is looking at the critical value. That is, if the probability of a t variable following 22 degrees of freedom or having 22 degrees of freedom, taking a value less than a is 0. Is actually not less than a, it will be actually greater than a, is 0.025, then what is the value of a? So that is a is basically here the critical value for the level of significance 2.5%. So let's see how to do that. So fire up Stata, and as usual, this is we have to go to the display dialog box. So you guys already know that to find out the display dialog box, we go to the data menu. And in the data menu, at the very bottom, we have the other utilities. In the other utilities, the first option is hand calculator. So we click on that. Let me just make it bigger, which is, yeah. So this is the same display dialog box that we are working with. Now, since we do not know what the function is, once we know the function, we can directly type it. But let's use the expression builder. Now remember, I am just showing you with respect to the t distribution. There are many more distributions or functions related to many more distributions are available in Stata you can work with. Definitely the standard normal distribution, the normal distribution with specified mean and standard deviation, chi-square distribution, F distribution, binomial distribution, many more distributions, hypergeometric distributions, and many more. So where are the functions? The functions are, of course, under functions. And since these are probability related functions, this will be under the statistical functions. So within functions, go to statistical functions, and then you can see the list of all the distributions related to which the functions are available within Stata. Now, at the top, it starts with, of course, these are alphabetically selected. So we scroll down towards the bottom because we are looking for the t distribution. So towards the bottom, we find that t. The moment I click on t, on the right-hand side, all the different functions related to the t distribution appears. Now, as usual, If you click on any of these functions on the right hand side, towards the bottom of the dialog box, it tells you what this function is going to do. Now, the first thing that I want to calculate is what is the probability that a t variable following 5 degrees of freedom or having 5 degrees of freedom takes a value less than equal to 3.21. That means I'm looking for that cumulative density. So that is basically this t function itself. And the explanation at the bottom tells me that there will be two arguments of this function within the parenthesis. The first argument is df, that is degrees of freedom, and the second is the t value. So first, double click on this t and bring it into the expression builder field. Now df, I already told you that the df we are going to use for this particular problem is 5 and t is 3.21. So this particular function is going to give me the probability that this particular variable or a t variable with 5 degrees of freedom takes a value less than equal to 3.21. Now, if I press OK, that particular function comes to the display dialog box, and I can press submit, and it will be displayed in your results window. So the probability is 0.988. So approximately 0.99. All right. Now, if the question was that I have to calculate the probability that this particular variable takes a value greater than 3.21, now that we can do in two ways. So we know that the t distribution is a symmetric distribution. So on one hand, I can do it as 1 minus this particular function. So that is one way of doing it. Or if we are not using 1 minus this function, then also there is another way. We can actually delete this particular function, go back to the expression builder, functions, statistical functions, t, and the immediately next function after the t is t tail. And that is basically 1 minus t. So if we are calculating what is the probability that a t variable following a t distribution with 5 degrees of freedom takes a value greater than 3.21, either we can calculate it by using the t function or t tail function. If we are using the t function, then it has to be 1 minus that t function. T tail function will give us it directly. And that explanation is also at the bottom of the dialog box right now, the moment I select the t tail function. So double click on t tail, degrees of freedom changed to 5, t is 3.21. Press OK, press submit, and the probability is, let me just scroll down a little. Yeah, the probability is 0.01186,437. Most likely you can do the mental calculation and see that 0.988135663 plus 0.0118647 gives you 1. All right. So that is how we can calculate the either the left hand side probability or the right hand side probability for any value specified. Left hand side probability will be, or the left tail probability will be with the t function, and the right tail probability will be with the t tail function. All right. So the next problem that I had on my Microsoft Word page was what is the probability that a t variable following 20 degrees of t distribution with 20 degrees of freedom takes a value greater than 1.96. You can do it immediately using the t tail function. So where is my, so again t tail, we just in the expression field itself we change the degrees of freedom to 20, change 3.21 to 1.96, and press submit. That will give you the probability to be 0.032 approximately. All right. So these are the right tail and left tail probabilities. What about the critical values? Because that is also something. Basically, the tables that we looked at mostly gave us the critical values. So the problem that I had on my on the page that I showed you was that what is the, if the probability of a t distribution of a t variable with 22 degrees of freedom takes a so let me just show you that. So this was the problem. What is the probability? Not the what is the probability? The probability that this t variable with 22 degrees of freedom takes a value greater than a is 0.025. Then what is a? So a is the right tail critical value here. So let's find out how do we do that. So again in Stata, same dialog box. No longer, it will no longer be t tail because t and t tail gives us probabilities. So go back to create, function, statistical, go to t again. Now, the function that we need is actually inf t tail. So it is the inverse of t tail. So t tail gives you the probability, inf t tail gives you the critical value. So inf t tail actually gives you the right tail critical value. Inf t gives you the left tail critical value. So click on inf t tail. It tells you that we have to specify the degrees of freedom and the right tail probability. So double clicking on it brings it up here. Degrees of freedom is 22. Probability that I specified was 0.025. Press OK. In the display dialog box, it has come in detail 22, 0.025. The first term is the degrees of freedom. The second term is the right tail probability. Press submit, and we get the right tail critical value to be 2.0738, or 2.073 or 2.074 approximately. All right. So let me minimize it again. Any question up to this point? This is how we can, so instead of T, we can use any other distribution as well. I showed you all the other distributions are there. So depending on which particular probability distribution you are working with, you can figure out the probability and also the critical values using the corresponding functions. Okay, there is a question already. Let's see what is it. Inf detail will give you the critical right tail critical value. So do I have any diagram somewhere? I should. Just 1 minute. Just give me a minute. Yep. So the question is, can I explain the inf detail function once more? I hope you can see my screen. So if this is the t distribution, then in the inf detail function, you will specify the probability of this kind of maroon shaded area. So once you do that, so what you have to specify both the degrees of freedom and the maroon shaded area in decimal values. In that case, it will, you can see that there is a T star, right? So the T star is basically the um, boundary line of that red shaded area, which is the right tail critical value corresponding to this particular probability. So the inf detail function gives you this T star value. Right? So that is what inf detail does. Another question, couple of questions actually. Um, Next question is, when do we use OK as compared to submit in the expression builder? Okay, I actually explained that in the first session itself, but repeating it again, submit will it will execute that particular instruction or whatever you have in the dialog box, but the dialog box will not disappear. It will remain there. But if you press OK, um, Stata will again execute whatever you have asked Stata to do, but the dialog box will go away. Since I am right now showing you things and I might use the same dialog box many times, I am keeping it there. Therefore, I'm instead of pressing OK, I'm pressing submit. But because otherwise I have to go back to the menu and bring the dialog box again every time. Shouldn't we use inftail for Q3 instead of infdetail? I don't think Stata has any function called inftail. The function in Stata is infdetail because in that first function that you have specified, inftail, there is nowhere the particular distribution specified. But in the function, actual function, which is infdetail, that is where there are the two t's there. The first t actually specifies that this is the t distribution. This is related to the t distribution because all other functions are also, all other distribution related functions are also in Stata follow the same rule. So for t distribution, it is inf t tail. For chi2 distribution, it is inf chi2 tail. So in the middle between inf and tail, you need some way to specify the particular distribution, and that is how the Stata functions are programmed. All right. Okay. All right. So no more question, I guess, because there is none here. So anyway, keep them coming. So that is the first thing that I wanted to show you, the p-values and the critical values. The second thing that I want to show is how to work with string functions. So for that, we need a small data set. Since I have not sent you any such data set on which we can work, what I will do is we will just on the fly type a data set. So go ahead, which I have actually asked you not to do that now. And that is open the spreadsheet, the Stata spreadsheet, the Stata data browser in the edit mode. So remember, I told you that in the we can do it many ways, of course, but let's do it simply using the icon. This icon, the kind of calendar looking icon with that magnifying glass, that is the data that opens the data browser in the browse mode where you cannot do any changes. But the same thing on the left hand side with the pencil, that opens up the data browser in the edit mode. So where we can make changes to the data set. Right now, there is no data set loaded in my Stata or your Stata either because we have not loaded anything. So let's just open that data browser in its edit mode. So as you can see at the top, it will be data editor, edit. There is nothing there, empty. So let's just type some words in the data set because we want some string values. I'm just typing some of the state names here. Haryana, let's say West Bengal, Bihar, Uttar Pradesh, Punjab, and that's it. 5 values are sufficient for me for this demonstration. All right, so we will work with this variable. So the name of the variable by default is var1 because we have not explicitly specified any variable name. We just started typing values for the variable. So Stata by default takes the variable name var1. Of course, we can change the variable name, but that is not something we are learning today. Now, let's see. How can we do some things with these string values? So we will calculate, we will not calculate, we will create several other variables, some of which will be numeric variables, some of which will be string variables, using these string values. So I told you that anytime you see the value of the variable in brown color, that means that is a string variable. Of course, these words will be string values. So I'm just waiting for a few more seconds so that all of you can finish typing. And then I will start showing you how to create variables using string variables as inputs. Question? No, nothing. All right. Let me assume that all of you have typed these words as your variable. So the first thing that I'm going to do is we are going to create some variables. So I need to hold on, minimize it. So let's just close this data browser or data editor, whatever you call it. And let's get back to Stata. The data set is there, as you can see in the variables window where one is there. That means this data set consists of one variable only. Now let's create a variable. Now what first variable I want to create? The first one I want to create is I want to count how many words are there in each of these values. So how do I do that? variable creation is through the data window, data menu. So go to the data menu, go to create or change data. Same way, the way we did it for numeric variables, same procedure, create or change data, then create new variable, and the generate dialog box comes. So now let me make it bigger. So this is the generate dialog box. First of all, if we are creating a variable, we have to supply a variable name. Let's supply the variable name word num. Why? It is simply, for me, it is short for word number because we are calculating the number of words in each of these values. Now go to create. Now we have to go to, again, functions, but instead of statistical, of course, we go to string functions. So once you go to string function, you can see there are many functions available under the string functions. And I think somewhere towards the bottom, we will have, because word count. So we are counting words, right? So it should start, I know that function name. So otherwise you have to look through the entire list. Since I know the function name, I am going to go to the bottom, and I know that the function will be word count. Otherwise, if I did not know it, I would have to scroll through the entire list and look at what I'm trying to do. Or do Google search and figure out what people are saying. So click on word count. Within parentheses, it says S. We have to delete that S and type var1 because that is what our variable is. We are counting the number of words in each value of this variable, var1. Press OK. In the generate dialog box, press submit. And as you can see, this command comes, generate word num is equal to word count var1. Nothing in red, everything is in black. That means things probably have gone all right. But let's look at the data set. So go back, open the data browser, and as you can see, yes, things have been done correctly. Haryana, one word. West Bengal, 2 words. Bihar, 1 word. Uttar Pradesh, 2 words. Punjab, 1 word. All right. So from a string variable, I just created a numeric variable which stores the number of words in that expression. So it's not just about name of states. You can have sentences here in each value. And you can count the number of words in each of those sentences. So whatever you can imagine, you can do it. It's limited by your imagination, really. Now that is, I converted a string variable in some way to a numeric variable. But let's say I want to work with the string variable itself. So what do I want to do next is, as you can see, appropriately, each of these words starts with a capital letter and the rest are lowercase letters. Let's say I want to convert all of them to lowercase. Let's just say if I want to do it. How can I do it? Go to that generate dialog box again. Let's give a new name, var1 lower. Delete this expression from here. Click on create. Again, go to functions, string functions, and let's go to L. It should be somewhere here. Where exactly is it? It should be somewhere. Nope, it's not there. Hold on. Should be somewhere. Okay. Most likely they have changed the name of the function. Yeah. Okay. So the function is str lower. So double click on str lower. Instead of S, again we type var1, press OK. That brings this function to the contents of the variables field. Press submit. Hopefully it has worked. Yep. In the results window, I can see it says generate var1 lower is equal to string lower var1. Everything is in black, nothing is in red. So let's go to the data spreadsheet. So as you can see, now all the state names are in only lower letters. So as you can see, I showed you two examples, but you got the idea. I think you got the idea that there are many other functions available. You can extract any part of these words. You can extract from the left, you can extract from the right, you can find out location of a particular character in the words. So there are many things that you might want to do. So on one hand, there are functions which will convert these string variable, this var1 string variable into some way a numeric variable like word num by counting the number of words, by counting the number of characters, by figuring out where a particular character appears in the sequence of letters, or it can create string variables themselves, like extracting some characters from any location within the word, uh, extracting just the first characters of each word. So all those things. So there are many such functions depending on how you want to manipulate the string variables. Those possibilities are there. All right. So I think I have given you kind of a rough idea of the extensive ability related to string variables that Stata offers you. Any question? Because that is something that I wanted to finish before I get into today's discussion. No question at all? All right, then let's get into what I wanted to do today originally. So I have been talking about something called reproducibility, which is basically replicability or repeatability of our work. And that is, I have said this also repeatedly, that that is the cornerstone of scientific quantitative work. Now, what are the different steps of reproducibility? If you talk to any researcher who works with quantitative data, you will probably find out everyone has their own steps for reproducibility, but roughly speaking, the five common steps that you probably will find in all of their suggestions are these. First of all, definitely pre-planning. For any work, you need to plan beforehand. Um, because without planning, your work will be haphazard, and haphazard work is something that is very difficult to reproduce. So pre-planning is essential. Secondly, backup. So all your data, all your results, all your original data, everything should be backed up. Excuse me. Third is definitely non-destructive usage of data. That is, you should always keep the original data set intact. At any moment of time, you might find that if you have lost the original data set, um, you have basically lost the ability to reproduce all of your work. So there should always be a copy of the original data set at your disposal. All right. The next two steps are recording of each step that you are doing related to the data analysis and documentation. So pre-planning, backup, non-destructive usage of data, these are not really data specific, um, irrespective of whatever analysis you are doing, these will be there. So I'm not going to talk about them in any detail at all. Within Stata, the two things that you need to, or the two things that we can do using Stata itself is, first of all, recording its step, and secondly, documentation. So these are the two things that we are going to talk about and see how to implement those using Stata. So recording its step and documentation. Now, there are two different parts of recording of each step. First is recording the results, and that is done through something called a log file. So we will see that log file is basically a text file in which all your results will be stored except for the graphs. So anything that appears in the results window will be copied in toto in that text file. So such a file is called a log file. So the records are the results are recorded. Results of any Stata session are recorded using the log file. So we will see how to create a log file. Secondly, recording the commands. So each and every step that we are doing, we will record that as well. Now, that is done through something called a do file, or sometimes we also call it a command log file, but we will use mostly the word do file. But remember that sometimes it can be called a command log file as well, a log file for commands. Now, commands can be recorded at three different steps. It can the commands can either be recorded at the end of a session, or during a session, or at the beginning or before the session. Now, the first one one that I have listed here at the end of a session, I recommended strongly against it. Simply because at the end of a session, we are all tired. After we have done a lot of analysis, we are at the beginning of our analysis, when we just open Stata for some work, we are very enthusiastic about it. We have all our energy. But after 1 to 3 hours of working with Stata, we are tired, our eyes are tired, we are ready to get into something else, something that excites us at that point of time. Therefore, if we leave recording the commands at the end of a session, 6 out of 10 times you will forget doing that. So the purpose of reproducibility will be lost, because you will invariably lose many sessions. You will forget to store the commands and you will close Stata, and then you will say, oh, I forgot. So do not leave recording the commands till the last moment. Therefore, I will suggest you to either do it during the session, which right now at your level, when you are just starting to learn Stata, that is what you can do, because you won't be able to do it before the session. Because to do it before the session, we actually need to know the commands. And then that can be done only by typing the commands, which I'm not even talking about. So going through the menu, we can either record the commands at the end of a session or during a session. And there, my strong suggestion is always record the commands during the session, not at the end. But I will show you both ways. Documentation can be done through many ways. Generally, we all keep a research log to plan every step of our work. Then we add comments to the do file, that is comments to the command log file where the commands are. We also add notes to the data and the variables. We also add labels to the data and the variables. So these are the different ways we document our work. Now, out of these four, research log is not something Stata specific, so I'm not going to talk about it. Notes and labels are definitely Stata specific, but I shall not have time, and it is a little bit advanced topic. So I will not even talk about notes and labels. So on the documentation part, the one thing that I will talk about and show you how to do today is the comments, how to add comments to the do file. So next, I will try to finish within next kind of 40 minutes that I have for three different things. One is show you how to create a log file or save a log file where the results will be stored. Secondly, how to create a do file, both at the end of a session and during a session. And finally, how to add comments to the do file. Now, since we are working with the menus, I will try to stick to the menu system. But remember that comments cannot be added through the menu system. We have to type the comments in the command editor. Or there is another way, we will see that later. So let's do those things. Now, the log file I told you that is a text file. But there are two formats in which Stata allows you to save the log file. One is called the SMCL format, or which is pronounced as SMCL, which is basically Stata's own version of HTML. Another is our plain text format. Now, this SMCL format is not very handy. It can only be opened properly within Stata. And if you try to send your log file to anybody else who do not have Stata in their computer, if they try to open it, it looks very bad. So SMCL is not a very good format for storing log file. So we will learn how to create log files using the text format. All right. So let's do those. Let's open Stata. So this data is open. I don't want to work with it. So let's just close it and open another So just open a new fresh session of Stata, change your working directory to the directory that we have been working with. For me, it will be um, your, which one was it? It was the Stata sessions directory. So it is in my D drive. So I have changed my working directory. Now, before I do anything else, before you do anything else, type something in your command editor. So I have not yet taught you any command through typing, but this is something that we cannot escape because there is no menu counterpart for what I'm going to do. So what you need to do is type exactly what I'm typing. So let me just make the font a little bigger so that there is no scope for mistake. So in your command editor, where is the command editor? It is just below the results window, right? In the command editor, type set space, ACT set space, log type, LOGTYP, log type together. That is, there is no space between log and type. So set space, log type, space, text. Not yet done, comma, space. Then type permanently. So set log type, text, comma, permanently. All right. Just now press enter. And in your results window, you should see this set log type text, comma, permanently. Underneath it, it says set log type preference recorded. Now, what did we do? By default, Stata tries to save the log files in its SMCL format because that is the default Stata log format. We do not want that. We want to save it in the text format. Therefore, I just set it so that the log files are saved in the text format from now on. We can always change. Permanently doesn't make it absolutely permanent. We can always change it at a later time to SMCL back again if we want to. So that is not a problem. So there is a question. Let me just check it. Does the only change the preference for this session or on future session? That's a good question. So the question is, does the permanently okay? So this anything that we type after a comma is not a command, is the option, which we will see or learn about in the next session. But anyway, that is not the issue. The issue is permanently does sets the log types for all future Stata sessions till we reset it again, or we, let's say, reinstall Stata again. So we can reset it using just set log type SMCL permanently. Or if we reinstall, then also this goes away. So permanently is not like it becomes written on stone. No, it is just that till the point we do not ask Stata to create logs using that SMCL format again, till that point of time. So yes, in this particular session of Stata and all future sessions of Stata, till the point we do not set the log type preference again, back again to SMCL. All right. So once it is done, Let's now create a log file. So before you do anything else in the session, we have to, so remember, you don't have to, next time you open Stata, if you have used this permanently option today, right now, you don't have to give this command back again. It's done for the time being. Next time you can open Stata, change your working directory, start your log file, and get set on working. No need for this command again. All right. Okay. So before we load a data set, before we do any analysis, let's just start a log file. How do you do that? Remember, anything to do with files will be through the file menu. So go to the file menu. Just below the change working directory option, we have log. Come to that, another small sub menu appears where it says begin. Click on begin. A dialog box comes, which ideally should point to the working directory that you have set. So session. Now I have my own kind of convention of naming files within Stata. I'm going to follow that. So today's session is, it is a session. So session, today's date is 22/01/18. 22/01/18. And it is a log file. So I'm naming my file as such. So I'm naming my file as session 22/01/8 _ Now the reason I'm using the log underscore, because generally I always save it when I do everything through typing as a .txt file. So I specify the um, extension as well, but for the time being, you don't need to do that much. Just type the name of the file and make sure that save as type is .log. Once you have done that, press save, and Stata will say that this particular log file has been opened. So now, whatever you do in Stata, if there is some output that is shown in the results window, that will be replicated, that will be echoed or mirrored in this log file till you close the log file or till you close this session of Stata. All right. So let's load a data set. So file. So I will just do 3 steps. I will load the wage 1 data set. Let me just tell you so that you can do it on your own as well. I'm going to load the wage 1 data set from the same working directory. I'm going to use the describe command to check the data set. I'm going to summarize the 2 variables, wage and experience, and that's it, because I think that is sufficient to demonstrate to you what is going to be in the log file. And then I will just close the log file. So open wage 1 data set. All right. Then I'm going to describe the data set. So data, describe data in memory. Okay. So that describes the data set. Calculate the average and some other things about the wage and experience variable. So statistics, summaries, tables, and tests, summary and descriptive statistics, summary statistics. Just type here wage, experience, that is XPAR. Okay, that comes as well. Okay, let me just show you that graphs will not be here. So let's also create a graph. So graphics, two-way graphics, Let's create a scatter plot. Y variable is wage. X variable is experience, let's say. Accept. Submit. So this is the scatter plot between wage and experience. So if you want to save this graph, we have to go to File, within the graph window, File, then Save or Save As. If you go for Save, then Stata will save it. Actually, here the dialog box comes, so that's not a problem. So you can change. Now, .gph is the Stata's default graph format. It cannot be opened in any other software. You need Stata in your computer. Therefore, it is always advisable, actually not only advisable, I strongly recommend you to save it either as a EPS file or a PNG file, either of the two. Because these two will behave best when you try to copy the file, open the file and copy and paste it in your Word file. So either EPS or PNG. PS is also fine. PS, in case those of you who I'm not entirely sure, if any of you work with LaTeX, then you will need it in PS format. But I'm not entirely sure if any of you who are attending the session actually use LaTeX or not. So PNG should always be the format. So let's just save this file as PNG. So scatter between what? Let's not name scatter. Let's name it wage experience wage and wage hyphen xper dot png and save. Then I'm just going to close the graph window, close this two-way graph as well, and I'm done. Now I'm going to close the log file as well. How do I close the log file? File, again file, log. Now the begin option is no longer there, so I'm going to click on close. So immediately the log close command comes. All right. So now let's go to the Stata sessions, that is the working directory that we have been working with. Go to your computer's working directory where you changed your working directory, right? So go to that working directory and you will see that there is a file called session, the name that we gave. I gave the name session 220118 underscore log. So this file is there now. Double click on it. It should open in your text editor. And you will see that all the commands that you did, starting with use the data set, describe, summarize, wage and experience, creating the graph, but there is no graph. Actual graph is not there. The command is there. Also, the command of saving the graph is there, but not the graph in itself. Then finally, the log close command is also there. So this is your log file of the results of this session. So no matter what you do, everything will be mirrored here. But where did the graph go? The graph is also in the same folder. I gave it the name wage experience.png, so that comes at the end. Double click on it, and the graph opens in Windows as photo viewer. If I now need to copy it to my Word file, I can just simply right click and copy and then paste in my Word file if I need to do it. If I need to paste any output from the results window, now this is definitely not the best way of getting output to Word file, but still, in a pinch, let's say I want, there are much better ways of doing this. But right now, whatever we know, based on that, if I need to present the mean, standard deviation, minimum or maximum of these variables, wage and experience, I can go to the log file, copy that entire portion, copy and paste it in my Word file. We have to do a little bit formatting. We have to change the font size and font type as well to line it up properly. And then the output is there in the Word file. Okay, any question about log file? There is already one. Let me check. Is there a specific advantage of using LaTeX along with Stata? No, it is none. I mean, I just wanted to just confirm that whether anybody is doing. LaTeX is something different. I mean, something different in the sense there is no advantage or disadvantage. It is, some people like to use LaTeX to write research articles because writing, especially when there are lots of equations, it is easier, much easier to handle compared to Microsoft Word. Moreover, there are publications, that is journal outlets, which require you to submit in LaTeX format, but there is no reason for using. Other than that, there is no reason, or there is no advantage or disadvantage of using LaTeX along with Stata. These are two disconnected things. It is just that if you are using LaTeX, Stata will, it's not that Stata will hinder your usage. There are ways of integrating the two. So that's it. Okay, no, that question was older question. Anything else related to log file? So creating the log file in text format is, just let me repeat myself. Now you can just email this file to anybody. If you are collaborating with someone, or you want to send these results to someone else, you can just email this log file to someone who may not have Stata in their computer. But still, everybody can open a text file in their computers. So saving this log file gives you that of benefit, that you can just send it to anybody and anybody can open it in their computer and see what the results are. All right. Okay, so let me just close this log file. So that is how you record the results. Now I will get into how to record the commands. But before that, let me just wait for maybe 2-3 more seconds to see if there is any more question regarding log file. Okay, very well. So next thing I told you is that how to record the commands. And commands can be recorded, especially when we are using the menu system, when we are not typing everything, that when we get to a stage where we can type our commands, then we will store the commands in a different way. But till that point is reached, till the point when we are working with the menu system itself, there are two ways of saving the commands. One is at the end of the session, another is during the session. So right now, since we just finished one session of Stata, it is easier for me to show you how to save the commands at the end of a session. How do you do that? Go to the history window. This history window contains all your commands, right? So let's say this is all that analysis that you wanted to do right now, and you want to save these commands. What you do is go to history window, right click there and select all. Then right click again and copy. Or you can use your keyboard shortcut CTRL-A, CTRL-C. Once you have copied it, you can do it many ways. You can open a text editor in your computer if you are comfortable with that. Don't remember, don't go for Microsoft Word or Open Word or .docx file. Those are not good for this purpose. You have to save it as a text file. So either open your notepad, or if you use some other text editor, for example, I think Mac has editor most likely, something like that, or within Stata itself, go to Windows, that is this window menu, and at the bottom of the window menu, you have do file editor. Click on new do file editor. Now, in fact, you can open this by clicking on this kind of the notepad looking thing to the left of data editor. That also will open a new do file editor. So whichever way you do it, this do file editor will open up, which is an inbuilt text editor for Stata. Now, since you have already copied those commands, you can simply CTRL-V or paste all of them here. So as you can see, starting with your change directory, set log type, everything that we did in this session has come up here. Now, definitely those two commands we do not need to repeat. Therefore, I'm going to delete them. The change directory and set log type, I don't need right in this do file. I'm going to delete them. Not only that, this is a very crucial part, the next thing that I'm going to tell you. Although in the log using command and the use command, if you check that entire file, entire folder path of the corresponding files have come. Delete those as well. Just keep the name of the file itself within double quotation. So name of the log file that I want to create is session 220118 underscore log.log. So keep only that. Delete the folder portion. Same thing with the use command. Just keep the name of the data file. Delete the folder portion. Name of the data file within double quotation. I hope you guys can all see, otherwise I can make it even bigger. Just hold on. Yeah. Similarly, graph export as well, I'm going to delete. So anywhere there is a file related command, I'm going to delete the folder part. I'll just keep the file names. Keep that in mind. So once you get your commands into the text editor, make sure that you delete all the folder links. Now, I will do one more thing, because already we have created this log file by the name session 220118 underscore log.log. So couple of things I'm going to do. One is I'm going to add a v2 here, hyphen v2 in the name of the log file, which simply says it is version 2 of the file. Also, at the end of this line, I am going to type a comma and type after a single space, type the word replace. Another thing that I'm going to do with this is go to the use, that is the use dataset command, type a comma with a space. I'm going to type the word clear. And finally, where it says graph export, that is the command that saved the graph in the PNG format. There is already the comma there, so I don't need to type a comma. I'm just going to type with a space in front of it. I'm going to type the word replace at the end of that line. Once those things are added, I'm simply going to save this file by a name. Now, what name I'm going to use? I'm going to use the name session 220118. That's it. I'm not going to add log or anything. The save as type is .do. It's okay. You can change it to .txt, but not necessary. .do is fine. And save. So now this file has been saved as session 220118.do. And this is my convention. The log file that will be created, because I will very soon show you how to use it once you have saved it later on to replicate your work. Every time I run it, this log file will be created, which will be session 220118 underscore log version 2.log. So my do file and the corresponding log file are always connected by the name. The do file's name that I just saved it is session 220118, and its corresponding log file is session 220118 underscore log. Then version 1, version 2, those are different things. But the same name with the addition of the word log. That's how I connect my do files and log files. So the do file is the collection of commands. This is a do file. Any question? Now, before I close this particular do file and show you how to use this do file later on, let me also show you how to put comments into this file. So let's say you are adding the comments while you are saving the do file at the end of the session. Or maybe later on when I create a do file simultaneously with the session itself, we might want to add comments later on once we have finished working. Then how to do that? Now, hold on. I will come to the question that you have asked, but let me just show you how to add comments. Now in Stata, anything that starts with an asterisk is a comment. Stata will just type that in the results window. It will not try to run that line. So let's say how to add comments to this particular do file. Remember, comments are absolutely essential. You will not remember, especially when you um, do complicated analysis. 2 days down the line, you will forget 50% of it, why you did something. Therefore, always add comments to explain to yourself and to others what you are doing and why you are doing something. So before that log using command, let's say add this comment. Start. Remember, always a comment starts with an asterisk. So start a comment with an asterisk. Always. Then another line. To create a log file. So this next line, this command line is creating a log file. Add a line, empty line above this use command, maybe a couple of empty lines, and then write with an asterisk, starting with an asterisk again. Load the wage one data set. Then before the describe command, add a few lines and type again to know what is there in the data set. Now you can understand. This way you can add as many comments, as much comments as you want. All right. So save the file again. Just click on that save icon. So this file will be saved with these comments. Now, if you are working with the Stata do file editor, you will see that all comments will be in green. So things are color coded here. So life becomes easier. So go ahead, type these things. Let me just check what the question is. Okay, that's a good question. Why are replace and clear options used here? Now, the issue is that most of the time what happens is when we are running a do, okay. Let me just hold on to that question. Let me show you how to use this do file later on, and then I will explain it, and that will be easier to explain. So just hold on to your question. So this is how we add the comments. Let's just close this file. In fact, close this Stata session altogether. Let's say I opened the Stata again at some other point of time. I want to reproduce my work now. You want to reproduce your work. You have that do file already saved. So change working directory. Change the working directory to that where you have everything. Now go to file menu. Go to there are many things that actually you can do. Many means at least two things. I am showing you one of them. So if you want to work with that do file again, you can open it by going to the do file editor and opening it through that menu. Or if you want to immediately replicate whatever you did, what you can do is go to file, above two options above that change working directory, you have this do option. So go to this do, and it will ask you do what. The file that we just created is session 220118.do. Click on that and then press open. Now, I hope all of you have been able to do it. And what did happen? Why not wage one? Didn't I save it? That folder is. Hold on. Something has done a bit problem. Okay. I created a problem for myself. Most likely for you guys, it didn't have any issue. So file, do, and everything that we did in the session just got replicated. See, scroll through the results window. You will see that you loaded that data set wage one. You described the things. You calculated the summary statistics again. You created that scatter plot between wage and experience, and you saved it back by the same name, and then you close the log file. But definitely, this time the log file's name is different, so you created a new log file. Go back to the folder. You will see that the new log file is there. The graph is, of course, just now it has been saved, and it has been saved by the same name. So there is just one graph. So this is the usage of a do file. Once you have saved it and you have not made any changes, you can replicate exactly what you did earlier, line by line in toto, again by running the file. And also in the results window, if you see, you check carefully, you will see that all those comments have come as well. Load the wage one data set to know what is there in the data set. All the comments that we added, those have come as well. So we have learned how to record our results, how to record our comments at the end of a session. Also, we learned how to add comments to the do file. Now, unfortunately, I do not have time to show you today how to record the commands simultaneously during the session itself. For that, you have to come back to the next session. But there was a question, why did I use? So let me open that do file. Why did I add these three portions? Comma replace, comma clear, and this basically comma replace, but the comma was already there. So these are all options. We will learn that anything we type with a command after a comma is an option in the next session. But why did I then add this replace option with the log using command and with the graph export command, and the clear option with the use command. Okay, let's first talk about the replace. What happens is log using command tries to create this log file. Now, when you are repeatedly running this particular do file, every time Stata will try to create this same log file by the same name. So if we do not have this replace command, replace option, what will happen is the next time I try to run this do file, maybe because I'm working with this do file after some tweaking, and because I saw that there is some changes I need to make to it, and then I want to run it again. But if I try to do that without this replace option, Stata will stop there because this file was created in a previous session when I tried to run this do file the last time. So this file will be there in the working directory. And the moment Stata tries to create this log file by the same name, it encounters the same file already existing. So Stata will stop, we will get an error message, and Stata will say that I can't do it. So to prevent that thing from happening, I am using this replace option. Same logic for this graph export as well. The first time I try to run it, it will create this file called wedge-experience.png. But the next time I try to run it, if I don't use this replace option, Stata will encounter a problem. By giving this replace option, what I'm asking Stata is to, if there is a file by the same name, delete that and replace it by this new file. So let me just show you what happens if I do not put this comma replace with this log using because remember, already this log file is there. Session 2201, where we have changed some variables, created new variables. So now if I want to load this data set again, a new data set, Stata will not do that. Stata will again give me that error message that there is a data set in memory. If you try to load a new data set, that data set from memory will be lost. So I'm not going to do anything, I'm stopping here. So that is why this clear option needs to be there, so that, but make sure that you actually want to clear the memory before you use the clear option. So that Stata will not give you the error message. Stata will simply delete the data set if there was any data set in the memory of Stata and load this data set anew. So these are the reasons we use this replace and clear options with these commands. Now we will learn about options a little bit more in the next session. And also we will learn how to save commands simultaneously when we are working in Stata itself. All right. So I'm already 4 minutes above time, but if you guys have question, I'm here. So I can stay back till there are questions. But my discussion for today is over. Okay. If you have question, just go ahead and ask, or else you are most welcome to leave. Good night. In that case, see you in the next session, but I will stay back till all of you have left to make sure that I do not miss any questions from you.